Hello, and wherever you are in the world, welcome to this webinar. We're pleased that you're joining us for today's session, and before we hand over to our panelists, we'll run through a few housekeeping details. Firstly, there's a member of IOSH team operating behind the scenes to ensure the smooth running of this webinar. They are available to help you should you need it, and you can message them using the chat function, which is at the bottom of your screen. You will also see a Q&A option. If you have any questions relating to the content, please post these here. A Q&A will be carried out towards the end of the session, and we'll get through as many questions as we can. At the end of the presentation, a feedback poll will appear on your screen. Please take a moment to complete this, as we value your feedback, and this helps us to improve our service to you and shape future guidance. Any value you gain from this session can be used as part of your CPD portfolio. We do not issue formal certificates of attendance for our webinars, but you will receive an email confirming your attendance, details of which can be used to record your CPD. Information on CPD can be found on our website. Where we have been given a speaker's consent, these webinars are recorded and will be made available on our website. You'll also be able to find a list of all our other recordings, as well as details of any upcoming webinars. Finally, details of all of this information will also be posted in the chat box shortly. We would now like to hand over to our panelists and hope that you, as listeners, enjoy the session. Thank you.
Good afternoon, and of course, good evening to our guests on a different time zone today. My name is Ed Hodson, and on behalf of the IOSH Railway Group, I'd like to welcome you to our seminar today. I'm sure many of us will admit that cybersecurity risk and health and safety risk is a topic some of us have not considered in sufficient detail, and my own wake-up call to this important topic took place less than a year ago at the IOSH Railway Group seminar last year. Therefore, I'm very pleased to welcome Dr. Emma Taylor today. Emma is an award-winning chartered engineer with more than 25 years of safety risk design experience across space, energy and transport. As the head of safety for digital safety at Razor Secure, a company which specializes in rail cyber security solutions, Emma is leading the integration of safety and security for the railway, both UK and worldwide. Emma was previously the principal strategy lead for asset integrity at the Railway Safety Standards Boards, or RSSB, as most of you will be familiar with. Here she led the response to the Cambrian ERTMS involving complex software-based systems. For any of our non-rail audience, ERTMS is the European Rail Traffic Management System. Emma is a fellow of the Institution of Mechanical Engineers and the Safety and Reliability Society, and also past chair of the Professional Engineering Institution and an enthusiastic promoter of standards, regulatory frameworks and guidance in bridging the gap between safety and cybersecurity. It is my pleasure to hand over to you, Dr. Emma Taylor.
Thank you very much, Ed, and good morning, good afternoon, and good evening to whoever and wherever you are in the world listening to this talk. I'm very pleased to have the opportunity to come and present. So just a quick check. Ed, can you see the slides okay? I'm assuming so. So I will. Excellent, brilliant. So thank you very much. Over the next 35 to 40 minutes, I am going to give you an overview of digital systems in the modern railway, vulnerabilities and opportunities. And as Ed mentions, I work for Razor Secure, who are a rail cybersecurity solutions company based in the UK, but operating worldwide. So when I first started drafting this talk, and I was in conversation with IOSH, I wanted to set the scope and I wanted to address a challenge. Coming from a safety background and working now across software-based systems and complex digital systems, I think it's important for all of us to be able to understand the important role that cybersecurity plays in the running of the rail industry. As people who work with safety, we all understand that safety is a cornerstone of the railway, but cybersecurity is also a foundation element. And as I was scoping this and preparing it with IOSH, I thought to myself, what I'd really like to do is make this session suitable for those without a cybersecurity specialist background, because the output for me at the end of this talk is for anybody and all of you, whatever your technical background, to feel to be more able to engage with your colleagues, whether it's IT, cybersecurity, so that we can all start thinking together and address the important target of having the railway operating safely from whatever perspective, or whatever vulnerability and whatever threats. And when I talked about this with one of my cybersecurity colleagues last week, he said, "You're going to do it from without a cyber background? That's a challenge." But it's hopefully, and I welcome your questions as we go along. So just a tiny bit of introduction about Razor Secure, because it informs what I'm talking about here in this presentation and our perspective and our understanding of digital vulnerabilities in the railway. We do a machine learning based product which is operated and installed on trains. We have more than 1,600 live vehicles, and we've protected more than 50 million passenger journeys. If you're in the sort of northern region of the UK, the trains you've been on are quite likely protected by ours. And here are some examples of our customers in the UK and the US. And we also work with train manufacturers and train operators as well that are not listed here. Just to show that when we're talking about here, we're coming from a position of direct frontline experience. Now, the railway is different, the railway is special. We talk about cybersecurity and there's lots of different interpretations, but rail has a specific cyber risk landscape. And as we all know, particularly at this current time, lots of operational challenges. And when you design and procure and put a train into operation, the cybersecurity protection needs to be available and operational and effective for the whole lifetime of the asset, over many tens of years in many cases. And we know that trains are complex and busy, and they have lots of other competing demands on their technical systems. People are looking for data outputs. Obviously, you've got the safety control systems. So whatever you put on board, and this is where we operate, it needs to be implementable without being a burden on the rest of the train systems. And on the right-hand side, specific to our product, it's a highly effective cyber solution. It's a distinctive technology. And I'm going to use these words here about behavioral anomaly detection. And by the end of this webinar, irrespective of your background, I'd like everyone to feel capable and open to understand how that actually works with cybersecurity, to take you from where we are now to, like in 40 minutes, being able to talk about some aspects of cybersecurity and digital vulnerabilities. So let's start with the current situation. We have different levels of ages and maturities of technologies on the networks in the UK, in Europe and worldwide. But even for more mature rolling stock, they are currently being upgraded. Wi-Fi is being put on board, more advanced signaling systems such as ERTMS are being brought on board. So whilst you might have a train that's digital from the factory gate and fully sort of equipped and specified, other assets on the network also have digital systems. And this retrofitting obviously gives greater functionality, increased connectivity, but it also increases digital vulnerabilities as well. So the talk is in 4 parts. I'm going to give you an overview of the train's digital systems. We all look at the railway from a physical perspective at the end of that section, maybe to look at it from a digital perspective, and then to ask whether this opportunity or threats that comes from this move to digitalisation. And as Ed mentioned in the introduction, I'm a fan and an enthusiast of frameworks, regulations and standards. And so I'm going to outline those, putting both safety and cybersecurity ones in front of you to help structure how you see and identify and address digital vulnerabilities. And then some thoughts, practical tips from where we see in our position as serving the railway industry of what people consider and what they can ask and how we can move towards safer networks and better operations. So we are at the position now where there is digitalisation at every level of a train. And this is taken from a technical specification on rail cybersecurity, TS 50701, which is going to be published on the 12th of July this year. And I think is really going to move things forward in terms of system level understanding of digital vulnerabilities and cybersecurity. At the most basic level, you have a train on a journey, you have passengers, train drivers and goods, and you've got 5 different categories of digital systems. Often when people talk about the safety, they focus on the signalling and the command and control. But just as important in terms of digital infrastructure are auxiliary systems, such as driver advisory systems, train comfort, passenger information systems and HVAC, and then public services. And that is like a wide local area network, a WLAN, and that is the kind of network that you may connect to with your Wi-Fi. And there's also video on demand. And I've highlighted on the right-hand side in the red box the kind of barriers, firewalls or routers in place that help to handle that flow of digital information and connectivity. So the train has many different levels of digital activity and performance. And of course, the train doesn't exist in the network on its own. It is part of a broader network. You have the operational control and maintenance, you have also the station, and you also have the trackside system with the move to digital signaling systems such as ERTMS. And I've outlined, again, all the locations where you have these firewalls, gateways, or routers, which are in effect the traffic cops handling the flow of information. And this train network perspective, it's very important to spend a moment looking at it as a way of calibrating how we see digital vulnerabilities. Because normally somebody that would work on brakes and somebody that would work on sort of CCTV or HVAC, or someone that would be on a station versus someone in the control room, wouldn't think that they are inherently connected. But when you take the digital perspective, you can see they are. And so access via one point in this network could lead to access via another, which is why those red boxes around those firewall gateways or routers are so important, because they help to handle the access via the digital information. So this train network that I've talked about is built up of these physical or Wi-Fi radio connections. You may remember when speakers of your hi-fi were all connected by cables, and now they're connected wirelessly. That's one example. You've got these devices to manage that flow of information. So you might think it's all digital. There's an awful lot of physical boxes and hardware and cables. So the train network is built up of these four component parts. And if there's one standard I would encourage people to read, it would be TS 50701 when it's published in only a few weeks. Because as a starter for 10, it really helps set out the image, the digital perspective on the railway. And here is the diagram I showed you previously, reframed in a slightly different way. And so you've got the categories onboard, trackside, infrastructure, and operations control maintenance. And just from that one slot, you can see that there is a significant amount of digital elements, and these digital elements are all connected. So when you start to think of digital vulnerabilities, you think to yourself, this may be connected to this. And it puts a different perspective on how you see the operations of the railway. Now, I've highlighted a few component parts here because as someone from a safety background, you tend to think of safety critical systems as being a priority. So this will be braking, this will be signaling. These are things used for command and control. So those are the red and the orange color codes. But when you start to look at the digital perspective of digital vulnerabilities, things which are auxiliary, comfort, or public are just as important, if perhaps if not more, in maintaining the safety of the operation of the railway. And I'll give you some examples here. So we'll start with the passenger information service, passenger information system, the digital readout display that we see on many trains. What would happen if someone would gain unauthorized access to that and put up a different message? One designed to worry or scare people, to say there is a bomb, or one that gives the wrong station information. The passenger information system itself doesn't stop the operation of the brakes of the trains unless there is a breach of the overall network, but it can be used to change the behavior of the passengers on the overall system. The entertainment systems, the Wi-Fi and the internet, and we'll go into a bit more detail on the technical connections, can actually be unauthorized access points as well as authorized access points for people looking to gain access to the control. So you might think entertainment Wi-Fi, that's not safety critical, but because of this connectivity, it does have an impact. The PA, public address, what would happen if access to that is blocked? And the CCTV, what would happen if the CCTV feed that you see is actually not the one that's actually happening? And then we've got other boxes and systems. So this railway asset model, When you put that in front of yourself, first of all, ask yourself, do you understand all these component parts? A quick Google will always help. And how are they connected? And what would happen if one of these malfunctioned? How could it impact the safe operation of the railway? This is starting to raise people's awareness of digital vulnerabilities as a concept and the digital systems which could lead rise to those vulnerabilities. And as always, when we all work in safety, there's no such thing as too simple or stupid a question. And the more views around the table, the more diversity of opinion, the more likely people are. And this is one of the reasons for doing this talk, is to encourage everybody to feel open and able to ask some simple questions. How does my CCTV work? How is the PIS connected? What's the password on it? Simple questions that help bring forward understanding. So I've made the point here that connectivity and digitalisation adds this vulnerability. It of course adds benefits, and naturally we're in the railway, and so there's lots of acronyms. And so this is from the standard network design, EN 61375, which sets out the principles and the protocols. And I'm going to sort of break it down bit by bit so that you can see how things are working in practice. So at the top, you've got the passenger network, and there's your Wi-Fi access points. You've got payment and entertainment systems, and that sort of communications gateway, passenger Wi-Fi. Now that is then separated, sort of segmented by Ethernet. Now, if you remember cables and connectivity, Ethernet is a type of connectivity and cabling system. So you have a switch there that controls access to the next stop. The next line is the operational Ethernet network on the train. And you're familiar with seat reservations and HVAC. There we are, CCTV, passenger information service, and another communications gateway. And then you've got another gateway because you're moving onto the train control system network. Yeah, and these are like the operational systems of the train. The event recorder is for an ERTMS type system. You've got traction and brakes, a GSMR, the modern railway communication, radio communications, and last but not least, trackside signaling network. If you could actually line up all those components, because they are all connected, they're all on this network. There are those routers, those blocks, those switches, those gateways and systems handling that information flow, but they are all connected. But if you could put physically those boxes in front of you, you would see access points, things that you can plug in. You would see also some that can be connected to by Wi-Fi, deliberately or via malicious act. And so even though it's a digital system, it's a physical entity and there are access ports. Now, one moment, because I have managed to use my mouse. There we are. So that's an overview of a train's digital systems. And I hope even in that just short run through, I've able to broaden your perspective of when you go to work on like the train or the track or the station, there's more digital systems around you. Now the question is, what benefits does this give us and what potential threats? So here's an example of a real world situation, and this is the passenger information system, a PIS display, and someone who had authorized access to it decided to program it to acknowledge somebody who is a Twitter fan. G loves trains. And so this is an example of how you can gain access and use a system for which it wasn't intended to. Now that's someone who was supposed to have that password, but if someone else who was not supposed to did, and it was an operational situation, they wanted to cause concerns, there we are. So you can see that password access, basic password hygiene, and making sure that the PIS is connected in a way that makes sense, and there aren't those ports and access points that aren't controlled, because this is the situation that you don't want to have happen. Control the information flow, miscontrol it, then you can have issues that come about. Another example, and this is in the public domain, the Stadler IT system was hit by a cyber attack. Now you might think yourself an IT system is not the same as like a operational technology, trains, but now because trains are strongly connected from trackside through to the train, and also the software is being updated and you have the flow of remote condition monitoring information, then actually if you get a problem on one part of that network, you have to then deal with it. And the trains had to be disconnected and like connectivity managed in order to avoid issues caused by the cyber attack at the main IT core, impacting the train operations, all connected. So sometimes when people talk about cybersecurity, they talk about different aspects. And I was talking to my sort of CEO only this morning, and he said, actually, there's about 30 different interpretations of cybersecurity. You can mean like controlling access to your laptop, viruses, passwords, Wi-Fi connectivity, and then all the train specifics. So when people talk to you about cybersecurity and digital vulnerabilities, it's often useful to say, which aspect are you considering? Are you considering the business enterprise, the IT that we all see as part of our day jobs? Or are you considering the control zone aspect of the railway? And this is the standard, which is the technical specification, which is TS 50701, the railway system. Now, the cybersecurity law and regulation actually ranges of bridges across both those components, but the implementation is different. And one of the key things when you're looking at trying to understand digital vulnerabilities, if someone comes to you and says, okay, we've got cybersecurity sorted, ask them what aspect of cybersecurity. Because whilst the good practice and principles that you find in an ISO 27K security management system standard is good, it's necessary, but it's not sufficient in itself. You need to consider the specific tailoring for the railway and how the operational technology or OT works as well. So there are obviously benefits and also vulnerabilities. We can all see with the greater flow of information how much better we can help the railway to run, how much better we can ensure maintenance and operations. But the connectivity and the standards help manage the vulnerability. So I'm going to introduce you to a concept which, forgive me for the people that are already familiar with it, it's called the CIA, but not the Central Intelligence Agency from movies and reality. It is 3 types of cyber impact principles, which when you're asking yourself, well, what are the digital vulnerabilities, you should consider all 3 of them together, because together they may all lead up to safety impacts. So C stands for confidentiality, and this often comes about with the EU GDPR regulation. Integrity: is the data what it's supposed to be? Can the data be trusted? Does the system operate as expected? If you're expecting a number 2, are you finding a number 3 there? And availability: is the information available when and where you need it to be? That's a perspective. So sometimes people say, I'm just going to consider the availability, but always check and ask yourself, a bit like in a hazard when you're doing what if this happens. It's always useful to consider all the different scenarios, because that will then help you understand the big picture around digital vulnerabilities. So we're moving a little bit on now to frameworks, regulations and standards. And I said at the start of the talk, I was going to look to try and enable people to feel able to ask cybersecurity questions, even if they don't have a technical background. And after I'd set myself the challenge and my colleagues said, gosh, that's going to be a bit difficult, I thought to myself, what's the best way to do this? And I thought that frameworks, regulations and standards, particularly if I take something with a safety perspective that we all use in our daily lives as like IOSH professionals, that might be a good starting point, because there is overlap as well as some difference. So here's a walkthrough of some frameworks, regulations and standards and the benefits they can help in giving insights on digital vulnerabilities. Now, I'm based in the UK at the moment, so I've chosen the Risk Management Maturity Model from the UK regulator, the ORR. There are, of course, other very high quality and beneficial management systems that come from other regulators and international standards as well. And many of them have in common the Plan, Do, Check, Act, PDCA loop. And this sets out the continuous improvement approach that you take to safety. And what is quite interesting when you talk through this and think about what it would look like if you apply digital vulnerabilities, at a first pass, it doesn't seem that different. You'd want to understand your risk, and we've talked through some of the examples there with like the railway asset integrity model. You'd want to sort of organize what you're going to do about it. It could be a degree of monitoring and put your plan in. And then you want to check to see how well you are doing in terms of managing those risks. And of course, we have people, processes and technology. It's not just the technology component of here. We're all familiar with the importance of management systems and safety culture and people helping prevent accidents as well. So you put in place and implement your plan, and then you measure your performance and you check and you investigate things that go wrong, that could be going wrong, and you monitor and you track. And then you look to see, you review your performance. Are you hitting the level that you're expected to, your lessons learned, and you update? And then you go back and revisit the plan. So from the outside, that actually doesn't look that different from what you do with safety to security. But as I'm going to run through, I'm going to highlight a few points which show the sort of difference and divergence. And as we come towards the end of the talk, highlight some strategies and things you can do to bring those two different component parts back together. So there is always, in every talk, a difficult bit. And this, unfortunately, is the difficult bit. This is the challenge that we have fundamentally when you're trying to incorporate a risk assessment, and this is from the IET Code of Practice on Safety Cybersecurity, and trying to incorporate it from the safety perspective to a security perspective. We're all familiar with setting the scope, doing the risk assessment, identification, analysis, evaluation, doing your risk treatment. This is from 3100, the ISO, but many risk management frameworks, assessment frameworks follow this template. And so it should be possible to do security-informed safety, surely. Same principle, same approach. But it turns out to be quite difficult because in safety, what you can do is monitoring and tracking of incidents to establish the likelihood of something happening using past data to help predict the future. But with security, it's an entirely different situation because things don't follow trends, and also monitoring is a lot harder. So you can't take the same approach to doing combined risk assessments. This is something which I would encourage people to read the IET Code of Practice. It's freely available and it sets out the detail of what the problems are. Basically, they've thought of the challenges involved in doing a combined security, safety, risk assessment so that you don't have to sort of struggle with them yourself. And why is there such a challenge there? Some cyber truths coming from one of my colleagues at Razor Secure. You can't just say, we are now secure. Security is a process, not a state. And this is because the condition of our digital trains is changing on a daily basis, as like the data flowing backwards and forwards is different, as the software configurations are different, but also as the threats coming from the outside. You can never fix your system definition and then assess it and say, that's it. So security is continuous and you must monitor continuously. And it's quite easy, relatively speaking, to count up your physical parts, but it's a lot harder when you look at like the digital parts. I showed you that digital network map, and you might think to yourself, am I actually going to be able to characterize all of that? You can't secure it if you don't know if it's there, or if you don't know what condition it is, or if you don't know what software version it is. And even if you can gather all of that together and say, I'm secure today, you're not quite so sure about tomorrow. So digital vulnerabilities are inherent always in transition. They are never sort of fixed and stabilized. I feel like I'm telling you something here that there's a problem with no solution, but as I bring it forward, hopefully I'll be able to show the approaches that you can use to sort of manage those digital vulnerabilities and take advantage of the data opportunities that we have in terms of providing an optimized service. So let's compare the safety frameworks, the Plan, Do, Check, Act, and the cybersecurity ones. When you put people together in a room, these are the kind of things. If you have safety people, they're PDCA. If you have cybersecurity people, they're identify, protect, detect, respond, and recover. And on the right-hand side there, it's all about this asset discovery and asset management and understanding about the threats and vulnerabilities, knowing what your system is and knowing the ways in which people are using it, and then understanding through detection what's actually going wrong, and then being able to respond promptly. This is one of the difficulties with the rapid variability of a system. Can you wait until next Tuesday to do something? Usually, no, you need to be able to identify, understand it, and return it to the state it want to be on a shorter timescale. So there is an issue of timescale and iteration and complexity. But the underlying principles, once you go past the terminology, are broadly speaking the same. So to another framework. Now, the UK National Cybersecurity Centre has done an implementation of the EU NIS directive, and there's a lot of good guidance material that's freely available on the website. And I've picked out a couple of the points here which are relevant to this digital vulnerability and managing it. I've highlighted how the understanding of the information flowing through the network is currently limited. And if you don't know that information, it's hard to know whether you're safe, because you're hard to assure yourself that security is in place, because it's the data that drives the understanding, the monitoring. So there are a few little principles here from the NCSC, and the CAF is the Common Cyber Assessment Framework. So secure by design, sounding all technical terminology here, but this is secure by design. It includes also security zoning. So you saw how I show how the network was split up into component parts and different systems controlling those different networks. That's a very simple example of the kind of security zoning principle. Then we got secure management, remote access controls. Again, that sounds a little complicated, but when I talk to you about people being able to access the PIS or plugging physically into the network, USB ports, that's an example of that. And there's also digital remote access. You want to be able to sort of segregate by designing, segregate the networks. And this is not just sort of physical separation, but it's also the protocols and the way that's used. And last but not least, you need that monitoring. Now, monitoring with this high volume of data isn't as easy as like monitoring specific incidents, because you need to be able to pick out the anomalies which are causing a problem. You can't proactively mine all of the information without sort of drowning in too much information. I've shown you the complexity. So anomaly detection is setting a baseline and looking for changes. Another aspect in terms of the cybersecurity sort of mindset is this idea of defense in depth and also zones and conduits. Now, these technical terms are explained in TS 50701 and also the cross-sector standard 62443. I'm just going to sort of lift the lid on some of the levels of it. So I've talked about the importance of preserving the data. I've talked about obviously the importance of awareness, and there's also physical, because digital doesn't exist in the ether. A digital system has a physical box, so you want to be able to control access to it. Perimeter, a physical perimeter, and also a digital perimeter. And often people don't tend to think about how a software is hosted, because it doesn't exist in the space of nowhere. A software exists on a physical entity, like a computer, and that physical entity computer also has an operating system. So the computer itself can be attacked, or the operating system can be modified, which means that the software then doesn't have a good environment in which to run. So there's lots of different ways that digital vulnerabilities can express themselves as well. So I'd encourage you to look at the defense in depth model as well. And another element where frameworks can be beneficial in understanding digital vulnerability is the system engineering lifecycle. Now, for anyone that works with system definition and requirement specification, this will be evident and standard good practice. For others, I'll just walk through the cycle and outline how it can be applied with digital vulnerabilities. So first of all, you need to sort of set out the system that you're looking at, the high-level concept, and define it. It's step 2, and how it's going to be used. Then do the risk analysis and evaluation, and then specify what you need your system to do in order to be able to manage the risks. Define those, separate those requirements out to the different systems, design, implement, manufacture, integrate, validate against the system requirements, put into operation system acceptance, and then operate, maintain, and update. So you can imagine if the early stages of the concept that you didn't specify cybersecurity requirements, it would be quite difficult to retrofit. So it's very important, even in the early stages of a system or a system change, you say, how would I ensure resilience? How would I address the digital vulnerabilities? Because that then generates requirements you can feed in. Now, we often find ourselves coming on board existing systems where there's maintenance, and we're having to be installed onto existing networks. And so that comes into the maintenance and performance monitoring side. But you'd always think that when you install new software on it, you are actually also changing the system definition, and so therefore maybe introducing new risks as well. So never be tempted, generally speaking, just to think that I've installed software, my system hasn't changed. Always think, I've installed software, Has it introduced any digital vulnerabilities? What additional content has it changed in the way my system's operating? How is the data flowing around? How has it changed? And so, like, coming towards the last stage of the talk, guidance and next steps. Hopefully I've built in your mind's eye an overview of a trained from a digital perspective and outlined some of the ways that, like, things can then go wrong or things can be used to create something going wrong, and then talked about how this all fits in with both the safety and the cybersecurity regulations, and flagged up some areas which might be more challenging to implement and others where perhaps there's a surprising similarity between safety and reliability, safety and cybersecurity, sorry. So last but not least, guidance and next steps. So I think, so first of all, some practical tips for anybody coming from whatever background. Use this railway physical architecture model that I showed you to understand how everything fits together. Do I have 3 PISs? Where are my CCTV cameras? Don't be afraid to then go back to the basics. Take a piece of paper and draw it out. It'll help you build the mental model. Then use what's already been done in terms of risk assessment legislation and standards. There is a lot of good guidance available already there, whether it's in standards or guidance documents or codes of practice. Excellent resources, both at the US level at NIST and at the EU level around the NIS regulations, and at the UK National Cybersecurity Centre. Many more other good resources are available in other countries or regions of the world. Because even though the general principles, though, are the same, I'd like to stress detection and monitoring, because this requires continuous improvement, both because of the complexity of the data flows and also because the nature of the threats, the external changes, will always change on a daily basis. So if you're going to focus on anything, once you've understood what you've got and understood what other people are telling you, then detect and monitor. And it's also important continually to refresh back to what the cyber requirements are, derived from various standards, assessment frameworks, and systems engineering, and making sure that when you're doing your next change, that they've been acknowledged and considered as part of the design process. Because if you don't specify it, and if you don't monitor it, then your system in itself still has the digital vulnerabilities, but it's not actually being addressed. And I've got then a couple more slides as I'm wrapping up on some questions you might want to ask yourself or your supplier or your sort of contractor or your colleagues. So on the asset management point, can you, as I said in the previous slide, identify all your digital assets? If you took a piece of paper and a pen, can you start to write down all of your digital paths? Do you know how they're set up? The software version? Do you know how they're connected? Do you know what sort of connections? And have you considered obsolescence? Now, obsolescence can be expressed in lots of different ways, but one simple example is for the operating system. You may remember earlier versions of Windows operating systems which stopped getting supported by Microsoft or that were vulnerable to various date changes. When you're considering and specifying hardware for like a 20 or 30-year period, you need to consider, will it be future compatible? Then we've got some principles around sort of network design and configuration, and this defense in depth and secure by design, and authentication. Are you sure that, like, the information that's being inserted into your network is the right network, and are you sure that it's supposed to be there? Touch of caution note about secure by design. I think that, like, it's necessary but not sufficient as it stands in order to ensure that you have your digital vulnerabilities addressed. Because of the complex nature of connectivity and because of the changing of all of software, even if, like, you could create the perfect argument, I'm secure by design today, even if you could, you can't ensure it for tomorrow. And this is why monitoring and so on is so key. And there we are on my next slide. Can you monitor your systems? And both the insider threat, which can be someone doing something without realizing it can create vulnerabilities, such as the person that programmed the PIS, and non-malicious mistakes, or someone with malicious intent. And then also, once this has happened, are you able to identify this happened through monitoring, and then you are able to reverse it? Unlike just taking a broken part and replacing it, a digital system is a lot more complex to identify and reconnect and reinstall the supporting software and rebuild the connections. And this forensic information is it's not a police word, it's the ability to decode all the software updates and all the transmission of data, all the sort of specific change that has been happening right up to the point when the system went wrong. And also we have supply chain risks. And because you're not the only person putting digital systems on your train or using them, and always be mindful of perhaps insurance exclusions. We all know about insurance exclusions on, say, our travel insurance. The same also exists for operations as well. I'm going to wrap up with just 2-3 more points here. Protecting the networks and monitoring the key systems is what you need to do to enhance rail cybersecurity to address those vulnerabilities. Risk assessment, and CSM is a European legislation. You need to monitor your fleet, do your asset management be reasonable incident response. That network protection and segregation, hopefully I've sort of decoded that language for you. We have intrusion detection of behavioral anomaly, and I'll finish up with that towards the end. And those key systems, those communication gateways, you need to have enhanced protection of those. So I'm going to move over just to the next slide here, to this security monitoring point. Security monitoring isn't just understanding through signatures of like a particular attacker trying to come at you, and it isn't just understanding and analyzing cumulatively through machine learning what the overall picture of the attacks is. What you need to do is set the baseline for your system. This is the behavioral anomaly detection, and set it the same way that the GP might take your blood pressure day on day and then look for changes from that. And that is the way that you understand whether there is a digital vulnerability that's being exploited or generated. And that's also the way that you understand your assets. So I'm going to wrap up just with one slide here now. I'm coming back to what Razor Secure do with their talks and what they do with their products. So we produce a security gateway, and I showed in some of the network connectivity, a position for a gateway. And this is a fully technical slide. This comes from our main sort of technical briefing pack. And if I'd started the talk with this, unless there's somebody here in the audience with cybersecurity background, they might be put off by seeing it. But hopefully now I'll be able to sort of put this in front of you, and you can see that it's a box. It's got cable connections and different types of connectivity. You can see that this box will be inserted into the network to help control the flow of information. You can see that this box would have a function. You see the word here of that traffic separation. So that's that firewall. And you saw how I had those highlighted boxes, the red boxes, separating out the network and chains. You can see I've talked about the importance of maintenance access. If people access various systems via USB ports, you want to make sure that person's supposed to be there and access. And I'm using the phrase cyber security event recorder because that is like the one place where you can have the single source of truth. So all of that information is coming through. You're establishing what the baseline is and you're looking for anomalies. And then, of course, it's a physical box into which you can install the software. So that's advanced tech used for behavioral monitoring anomalies. And that is the sort of thing that can be deployed on a train and a journey to support throughout the network, everything from signaling, command and control, right down to the public services and like the PIS and HVAC. And on that, I'm going to wrap up and say thank you very much. And hopefully I'm still within time.
Thank you very much, Emma. That was extremely interesting. My train journeys will never be the same again, even looking
Yes, hopefully still positive, hopefully positive.
Hopefully very positive, but more aware. I said earlier that, you know, I wasn't woken up to cyber risk until just over a year ago. And now I've had another wake-up call, the alarm's gone off again. For certainly the safety professionals who may never have linked the in-depth requirements for safety and security. Interestingly, one of the first questions I had from Mirza Hussain was that are security and safety disciplines crossing the functional boundaries, and can they not be fully isolated? I think an interesting question because it's one we discussed at the very beginning, that physical security is integral to cyber security and it's complementary. So I think that probably answers that question.
It's true. Yeah, go ahead. You're right. For everybody that's sitting there thinking, oh, digital's nothing to do with me, what we do in preserving the physical integrity of the railway, both access to equipment and access to site is just as important. because sometimes in order to exploit those digital vulnerabilities, you're going to need to be physically there. So yes.
And one from Phil, who's leading the shaping of standards and guidance in GB Rail to address the emerging risks? And where can we find out more information as it's produced?
Well, the UK is part of the sort of broader sort of standards community. So we have international standards and like the TS 507 or the Senelec standard. So the UK representation for many of these is done by the BSI, and many of the industry representation is done by the RSSB as well. And I think the sorry, go ahead, Ed. And so going to the RSSB is one good place to look to see where like the standards and guidance associated with GB Rail is one source. I would encourage people to go to the National Cybersecurity Centre's resources. They focus on making it accessible to non-specialists. There's a cyber assessment framework. If you wanted to know where to start today, you could get that. You could print it out. You could say, do I meet it? Do I partially meet it? Do I not meet it? Do I not understand what it means? That's a rationale to go and carry on learning. So the National Cybersecurity Centre, both generally and for your personal professional cybersecurity and also your rail cybersecurity, do produce resources. And I'd encourage people to learn from the IT cybersecurity, because even though IT is not the same as rail cybersecurity, there is some overlap. And by waking yourself up to the way things can go wrong, looking at the briefings and news reports, you can learn a lot. So NIST also, the US. So NIS is the European regulations and NIST is the US guidance.
Which brings us on to legislation from Catherine. Does new legislation identify periods for detection and monitoring? For example, safety critical or other?
That is an excellent question. Now, unfortunately, I can't answer it because periods, in the way I understand it, defines a sort of a period of time. Now, there are notification periods within the NIS regulations themselves. If you have like an incident that breaches certain thresholds, then you must tell the relative legislative authority. This could be different in different European countries. So I'd say that like for certain thresholds under NIS, yes, there is a requirement, but I would encourage people to go to their national legislator in order to identify what that is. From the safety perspective, there are requirements to report into SMIS, which is the UK's safety reporting system. And there's also requirements to do safety alerts through NIR Online. And NIR Online has a European equivalent that's SATE. If you identify something which has got the potential to impact safe running of the railway and a direct relevance to safety critical systems, you do need to tell people very promptly. So it depends. It depends on the legislation, it depends on the system, and it depends on custom practice. But the most important thing is, of course, being able to identify what's happening.
Quite happy to answer more questions, Emma.
I am indeed.
Okay,
I can see them coming through.
Yeah, they are. Is there accepted good practice for managing potential vulnerabilities, such as technician using a compromised USB stick?
Ooh. I'll answer with a little small deviation. I used to work in the space sector, and I spent some time at a US military lab that was also doing geological research. I'm not US military, I was doing geological research. And I remember going on site, and this was 2005, and they basically glued up the USB ports. We literally glued them up so you couldn't stick anything in. So I think that the kind of house rule is really don't stick something in unless you have to. The difficulty is with a USB stick is they're very practical and can be used for passing information on, but they're also a mechanism by which you can insert things into the network that you shouldn't. Now, the question, I think the question sort of implied that the technician already knew it was an infected USB stick, in which case, talk to your IT cyber security people, your department. Don't put it in and think, oh, it'll be okay. That's a challenge.
Very interesting question from Kate. Can the security product itself introduce vulnerabilities?
I like the way you're thinking, Kate. I think that this is exactly the right kind of attitude. I'm going to put something in, it's got security on the label, but does it introduce any vulnerabilities? Of course it can. Anything that you make a change into the digital network can introduce vulnerabilities. I can tell you a little story. I've got to make sure not to give too many identifying details. Obviously, we make a security gateway, and there's this sort of way of testing called pen testing, which is penetration testing, which is where you give somebody the authority to try and break into your system. And they came to us to do a trial. And they sat there and they sweated away for 2-3 days. I heard from our CTO that they were there and, like, you know, he couldn't get in, whatever. At the end of the 3 days, he had a little report and it had 2 lines in it because he couldn't find ways. So I guess that, yes, anything that you introduce can introduce digital vulnerabilities, but test it and ask the suppliers, what have you tested? And it's a very British word, bamboozled, but don't let yourself be bamboozled or confused or put off saying we're secure by design or we blah, 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 long string of acronyms. Just say, show me, explain to me, and keep probing. Good question. I like that. I like all the questions.
From Ramesh, is TS 50701 purely railway based, or does it apply to different industries?
It is railway based. It's written for rail cybersecurity, but it does actually is informed by 62443, which is a cross-sector standard. I think you can look at it and not be a rail professional, still learn and understand a lot. And sometimes perhaps it's easier to understand cybersecurity through a system that you're familiar with. We all go on trains. Some of us more in the past than we do at the moment because of the pandemic, but trains as a system are actually familiar. We see a train, we see a track, we see a station. So there's nothing stopping people picking it up and reading and looking to understand it. It may be a route into understanding for other sectors.
From Mirza, do rail or national transportation systems need a dedicated hardline connection for ISP to avoid any cyber terror to improve the safety and security of the operations?
So this is an interesting question, because imagine if I said yes or no to that, and I'm not a national transportation system representative. The act of answering yes or no gives somebody information about the nature of the network, and that then helps them identify digital vulnerabilities. So in safety, we're used to talking very openly about it, but this kind of sort of question, do you need a dedicated hardline or not? And I'm not in a position to make an assessment for it. The act of answering it provides some information to somebody that may be looking for a vulnerability. So always look to be cautious about the kind of information you put out in the public domain.
Question from Stephen. Authorising cyber requirements was mentioned. This sounds like quite a specialist task. Is this something which currently happens within the rail industry, or is it aspirational role, and who would undertake this, e.g. rolling stock manufacturers or operators?
So to answer the last part of the question, both rolling stock manufacturers and operators are in the position of authoring cyber requirements, because it's not just design, it's also operation. So it could be a requirement to monitor and update and look for anomalies or report changes or have some form of dashboard arrangement. And actually we work both with manufacturers and operators, so it comes through. Now the question is, it does happen, but it doesn't happen consistently and broadly. It should be happening more consistently and broadly because the legislation is starting to ask people to take an overall system view of cyber resilience or digital vulnerability or software security, however you want to call it. But we're seeing it's variable take-up or variable awareness. I don't know whether it's specialist. I think it's probably better, rather than somebody thinking I can't write any requirements, so I'm not going to put any requirement down, have a go at writing a requirement. And it could be as a simple functional one. I want to understand the flow of information from this system to this system, and I want to understand what normal looks like, and what trigger, at what point should I be concerned? Because that then allows you to have a conversation with the supplier of, like, your equipment or your train or your service.
I'm a little bit worried because I'm sure one of my questions has disappeared.
That's okay. We've got plenty of questions coming through.
Yeah, I thought it wasn't a cyber attack because it's disappeared. It was a blue box that disappeared somewhere. Dimitri, thank you. Could you please clarify a bit of what kind of 3 projects these boxes are now deployed? Not quite.
So I guess you're talking about the security gateway. I don't think I can really talk about our customers in public generally, apart from the ones that are on the sort of first slide. I think that because some of them are just in the process of like arranging, we've got big projects and like things will change. So I know it sounds a bit sort of trite, but do please check out on our website for listening and read up about our security gateway, because we'll announce various customers there as they come on board.
I'm pleased to say I found the question that I lost.
Excellent.
From Ian, is there accepted good practice for managing, I think we did have that, potential vulnerabilities using a compromised stick? I did answer it, sorry.
That's okay.
Okay, yeah, no, I'm quite happy that I did cover all the questions. Oh, not a question, a comment on the subtitles. These work very well, accurate and responsive, and are a great benefit to those with hearing issues. Thank you very much, Keith.
Thank you. I have to say, I work with people who have got hearing difficulties, and they were the one that encouraged me to use closed captions. And so to everybody who's still on the call and listening, just go to your Teams or your Google Meet, switch on the CC button and learn about this technology. It's fantastic for communications, particularly in this COVID times.
Okay, I think I've come to the end, and it's quite good timing at 14:56, Emma. So I'd like to conclude by, first of all, thanking you for the excellent presentation, and on the feedback on the chat. I think most of the audience have agreed with that and found it as interesting as I did. Thank you very much to everyone who's joined us from wherever you are in the world, and we will now close this webinar. Thank you very much, Emma, and thank you very much to our